Hi, this is Adam Griffin with the first video for this week. So this problem is going to be number 2, which deals with the thin lens equation and determining where images are relative to where an object is placed and the focal length of the lens. So question 2 goes like this. So there's a candle placed 140 centimeters from a converging lens with a focal length of 40 centimeters. And we're assuming that the lens has a diameter of 5 centimeters. So for part A, how far from the lens should the screen be placed to see a focused image of the candle? So right here we have a little diagram. Our distance from the candle to the lens is S, or 140 centimeters. The focal length is 40 centimeters. And the diameter of the lens is 5 centimeters. And we are trying to find S prime, which is the distance from the lens to the focused image. So using the thin lens equation, which is 1 over S, so 1 over the distance from the lens to the object, plus 1 over S prime, which is the distance from the lens to the image of the object, is equivalent to 1 over the focal length of the lens. So we can change this equation up a little bit, and we can solve for 1 over S prime, which equals 1 over the focal length minus 1 over the distance to the object from the lens. So if we plug in these, we get that 1 over S prime equals 0.0179 centimeters to the negative 1, and then we just take 1 and divide it by that, and it gives us S prime, which is 56 centimeters. So 56 centimeters is how far away from the lens the screen needs to be placed for the image to be focused. So for part B, 1/2 of the lens is covered with a card. What will happen to the image of the candle? So this part deals with ray tracing, which we learned a lot about in the book. So we have our focal points right here, and then our candle is this entire height right here, and then the card is blocking the bottom half of it. So when these light rays come off of the candle right here, they hit the lens and then are refracted towards the focal point on the other side. So what the image ends up being is whatever part is not covered by the card. So in this example, it's the bottom half. We will see the top half of the candle, and it will be flipped upside down because these rays up here go down through this focal point right here, and then this bottom half we don't see because there's a card right there. So the image will be cut in half and showing the card where it is blocking the candle. So that is part B. And then for part C, it's asking a card with a circular hole of diameter 1 centimeter is placed in front of the lens. What will happen to the image of the candle? So it's placed right here, and we have a 1 centimeter hole in it. The rays coming off the candle this distance is also 1 centimeter because everything else is blocked. They go through, and then anything above this center axis is going to refract towards the focal point and then be kind of underneath this axis. So this little section of the candle that we would see is flipped upside down, and then the rest is covered by the card. So the image of the candle will be a 1 centimeter in diameter circular image, and it will be flipped upside down. So part D, the card with a circular hole of diameter 1 centimeter is placed so the hole is near the outer edge of the lens. What happens to the image of the candle? So pretty much the same thing as part C. These rays are coming off, and they hit this. So if it's higher up, the angle of refraction is going to be a lot steeper. So it's going to go down. So it's going to be lower the higher up it is, and that means that the image will also be inverted, and it will still show a 1 centimeter in diameter circular image of wherever this hole is. So if it were up top, we would see the flame just upside down and towards the bottom. So that is how you solve problem 2. and thank you for watching.